Hey guys, so we're going to be looking at graphs today, and this is a review from last year. It should be a review from last year. We did a lot of graphs, I know, and so we're just going to add a little bit more information since we're in 7th grade now. The first one we're going to be looking at is a stem and leaf plot, and it's collected data, and all that means is it's just numbers. It's numbers where the data is split into a stem, which is going to be the first digit, and a leaf, which is going to be the second digit. So this is your stem on this side, and this is going to be your leaf. And how we collect this data is all this means is this is your tens digit and this is your ones digit. So this means 69. So when I'm rewriting my data, I'm going to write 69, then I'm going to write 72, then 73, 76, 78, 79, 79. So I'm going to rewrite all that. 72, 73, 76, 79, 79. Now I finished with the 60s and I finished with the 70s. So this is going to be the what? The 80s. So you have 82, 82, 84, 86, 88, 88, 89. So we finished the 80s. Now we have 90, another 90, 92, 95, 97. This is a lot of data. 90s are done, and then you have one more. And see how this says 10? Well, that means this is going to be 100. Basically, you just read it as if there wasn't this line here. So this is going to be 100. So now we did all of our data, and that's all you do. That's how you list it. Make sure you notice this goes in order from least to greatest, and then it goes in order from least to greatest this way too. So your small numbers are here and your bigger numbers are here. Alright, so now we got to pull out data from this chart, and this is a double stem and leaf plot. And this got cut off on mine, but this means 23. That's kind of like what we just saw. And this means, sorry, it means 50. You read it backwards. So we'll start with third period first because that's like the normal one. So basically we're just going to ignore everything on this side for now. So on this side we have 0, which is our 1. So all that means is it's just 0, 5, which is just a regular 5. Then you have 6, which is just a regular 6. Do you need this 0 here? Probably not. So then we did this side. So now we have 11, 11, and 14. Next you have 23, 24, 26, 26. Now remember, we're only looking on the right side of our graph right now. You're going to want to write small, by the way. You don't have a lot of room. 35 is next because we finished the 20s, 35, and then another 35. After that, you have the 40s, which is 47, 49, 49, and last you have 53 and 57. Okay? First period, so we finished this side now, so I'm just going to scribble that side out. Now we have this side to do. This means, remember, 0, 1. This is always still going to be your tens digits, okay? This is always going to come first, whatever's in your stem. So you have 1 and then 2. Now you finish this. Then this is, you draw your tens digit first, and then you have a 0, so this is just plain 10. Then you have 21, 26, then you have 33. Okay, see how there's nothing right here? That means we don't have anything on the 40s on this side, so we can just skip right over and we can just go straight to the 50s. So you have 50, then you have another 50, then you have 58. So we have 50, 50, 58. Alright, super simple. Now after you list it in order, of course you could find your mean, median, mode, or range, whatever they're asking you to find, or you can just look at the data and use information from it. So don't forget, this is your key. Really important to always have your key. Alright, next is bar graphs. So bar graphs, you've seen them a million trillion times. It's just a graph using parallel. Remember, parallel is something, two lines that are never going to intersect. Parallel bars of varying lengths Asked to illustrate collected data. Remember, collected data is just a fancy word for numbers. So this is just, I mean, super simple. This says scores down here. This says students. So one student had a score of 40. 2 students had a score of 50. 4 students had a score of 60. 3, 70. 6 had an 80. And 2 had a 90. So nobody got 100. That's sad. This is called a horizontal. Remember, horizontal sounds like horizon, so it goes to the side. Horizontal bar graph. And all it is it's this, but it got flipped on its side. So this just means country 5 had about, that's a not even, about 100 of whatever this is. Millions of toners? Maybe, was that what it says? I can't even read it. Country 4 had about 150. Country 3 had about 250. Country 2 had Country 3 had about 225 maybe right here. Country 2 had about 250. And Country 1 had a little bit over 300. So really simple. You read it the same way we read this one. It's just flipped on its side now. This one, you see how we have 3 different colors? Well, what do these colors mean? Well, you have to come over and find and look at your key. Remember, your key is always important. It tells you how to read a graph. This just means that this is youth vote versus everybody else. In 2000, this is the percentage of 25-year-olds that voted. This is the percentage of 45-year-olds that voted. This is the percentage of 65-year-olds that voted. Now, how did I know that these colors went with those ages? Well, I looked over here and I saw that blue was 25 years old, so I knew that all these bar graphs were talking about people who are 25 years old. The red was talking about people who were 45 years old, and the yellow or orangey color was talking about everybody who is 65 years old. So I know yours doesn't really have those colors on your copy because it's black and white, but you can pretty much get the gist from this. So this is just showing you how important it is to read a key. Next, line plot. It shows the frequency of data on a number line. Now, frequency is a funky word, so we went ahead and put you a definition, and frequency is, all it means is how often. It's the number of times you see something or rate of how much something occurs. I have a feeling we've seen this before. So frequency, remember, is how often, how many times, basically, how many times of a number. So how many times did 1 show up? Well, you come up here. Now these X's means it only happened 1 time. So we put a tally mark and it's just going to be 1. 2 happened how many times? Just once. 3 was twice, so we're going to put 2 tally marks. 4 happened 1, 2, 3 times. 5 happened 1, 2, 3 times. 6 happened how many times? 7, or twice, sorry. 7 happened how many times? That's a tricky one. Okay, none. So we just aren't going to put anything. You just leave it blank. 8 happened twice. 9 happened 1, 2, 3, 4. And 10 happened, again, none. So pretty simple. You just have to make sure that you're looking above the correct thing. And these X's, you have to know these X's represent 1. 1 vote, 1 anything, 1, just 1. Alright, so remember we were talking about these X's mean 1. Well, these X's now mean one candy, basically is what it's talking about. 1 candy. So let's see how many frequency. Remember, frequency means how many. How many reds did we have? We had 1, 2, 3, 4. We had 5 reds. How many purples did we have? 1, 2, 3, 4. We had 1, 2, 3, 4, 5, 6, 7, 8 yellows. I bet you could fill in the rest on your own. We had 2 oranges, and we had, count them up, how many greens? You should have said 7. So that's just really just looking at the graph again and counting your X's, because remember, X's stand for 1 something, so 1 candy. Line graphs. Line graph is a diagram of lines, line graph, lines, made by connected data points showing the changes in value of a variable quantity. That's confusing. Basically, it's just showing you change over time. Just what happens as time goes on. So, for instance, this is talking about weather, because I see that we're talking about temperature. And I find my key and I see that red, or this top, okay, I'm going to tell you that this color is red. On your graph it's red, obviously, because it's the color right here. This one is going to mean highs and this one's going to mean lows. So on Monday, the high was about, what, 82? The low on Monday was 70. And then this one's probably about, what, 78-ish? This is 66-ish. Guys, this is just like stuff that you see on your weather app on your phone. So like on Monday, it would say Monday, and then it would say the high is 82. The low is 70. This is stuff you see every day, but it's now just put into a bar graph. And then on Tuesday, it'll tell you the high is 78. The low is 66. So it's really, I mean, you see this all the time, it's just in a different format now. We could keep going. This would be 65, this would be 75, this would be 65, this would be, I don't know, 54 maybe, 61, and 70. Okay? Nothing too crazy, it's just showing you what's happening over time. You have a graph on your line graph data that we didn't obviously put in the PowerPoint, and pretty much you read it the same exact way. Find the point, look at what your y, remember y to the sky, y goes up and down, and you can just look at it like that. We might be talking about that actually in class. Circle graphs. Now circle graphs is something we're adding a little bit of information to just because now we know stuff about percentages. So circle graphs is a graph representing data by dividing a circle into sections or sectors with percents. Okay? All percents in the graphs will add up to what? It's going to add up to 100. Remember, percent equals 100. Percent means hundreds, remember? Always estimate by fourths. Now I'll show you what that means. Basically you divide your circle up. If this is 100, if you divide it into fourths, each one's going to be worth 25%. We'll talk about this more in a second when we do an example. The main idea is use percent of total, or percent of, for Ms. Hitchcock's class we say percent of a number. You change your percent to a decimal by doing Dr. Pepper, and then you multiply by the total. This is stuff we've been doing all year. It should be up on the wall in almost all of the classes that you are in right now. Okay, so the circle graph directly below shows the results of a survey of 60 teens who were asked about their favorite sports. Use the graph for exercises 1 through 3. Well, here's our exercises right here. Alright. Let's break this up first. Remember we said we were going to talk about fourths. Well, I'm going to divide this into fourths. Okay, so I know that baseball is about 25%, right? Because if this whole thing's 100 and this is divided into a fourth of 100 is 25%. Or if you had a quarter, if you had 4 quarters, 1 quarter would be worth 25 cents, right? Okay, now this section right here is going to be worth 25%. So if we divide it up, half of 25 is about, I don't know, 12.5. But it looks like football has a little bit more. So what do you think we could use as this percentage? If this plus this has to equal 25, but football has a little bit more, we'd probably say it's around, what, 13%? So if this is 13% and this whole thing is 25, then tennis should be worth how much? 12%, right? Soccer is a little bit different because soccer covers this whole area right here. Do you see that? So soccer has 25% because we know this part of the pie is worth 25. But then it has this part of the pie too, and it shares it with hockey. You know that hockey, I mean, it's not looking pretty big, so it looks like it's a little bit less than tennis. So what do you want to say? Like, we'll say it's 10%. So if hockey's 10%, how much would this be? Well, if this whole thing right here, remember, is 25, and we already used 10, this one should be 15, which means that soccer is going to be 25 plus 15, which is 40%. Alright, so now that we broke down our graph, we can start answering these questions. Did more teens pick baseball or hockey? Well, let's look at our graph. Does it look like you don't even need the numbers to answer that question. Does it look like more people pick baseball or hockey? Definitely baseball. It's a bigger chunk of our pie. So, baseball. About what percent of the teens picked tennis? Well, remember we already broke it up. So, you do this little squiggly line. You do 2 of them because that means about, because we don't know for sure, but it looks like it's about 12%. This just means we estimated. According to the survey, 40% of teens chose soccer. Ooh, look at us go. 40%. Okay, so we did it right. This was 25 plus 15 would be 40. How many teens chose soccer? Well, this isn't asking for a percent anymore. It's asking for an actual number. So look, we put a little hint down here for you. And percent of total for Miss Smith's or percent of number for Miss Hitchcock's and Miss Grenades. So what was the percent? Well, they told us our percent was 40%. So look at the top. It says first we have to change our percent to a decimal. So we can't just multiply. We can't put 40 here because we have to change it to a decimal first. So we use DP. We have 40%. We're at a percent. We need to get to a decimal. So we go 1, 2 over. So 40% as a decimal is 0.4. Now we have to multiply that by the total or the number. Alright, so what are we going to multiply that by? What's our total? Our total or our whole number? Well, I don't know. The question didn't tell me, but this question did over here. 60 teens. That was our whole. So 40% of 60 teens total. I lost my clicker. So 0.4 times 60. Come over here. Multiply it together. 4 times 0. 240, is that reasonable? No, because how could I have 240 if I only have a total of 60? So I know I missed my decimal. So I move 1 decimal in my answer. So I know that 24 teens chose soccer as their sport. Alright? Let's do another example. That was a lot to take in. Alright, now we're talking about pies, so hopefully you don't get hungry. Your paper says, what is your favorite kind of pie? The pie chart shows 175 people responded to this question. Alright, so the first question was, what percent of those surveyed chose apple pie? Well, I don't know. But I do know that this says 20%, this says 15%, this says 32%, and this says 9%. So if I have all that information and I'm just looking for this information, how much does this all make up? Well, you should remember that percent means hundreds, or percent means 100, so we know that this whole pie is going to be worth 100. So if we add everything up, 20 plus 15 plus 32 plus 9, you should get, this is 7, 16, 1, 2, 3, 4, 5, 6, 7. So this whole thing right here is 76%. So if this whole thing is 100 though, and I already used 76%, how much do I have left over? Well, you can just subtract and you'll find out that apple pie is going to be worth 24%. So what percent chose apple pie? 24% chose apple pie. How many people chose apples? Uh-oh. Well, if you know that 175 was your total, and we know that 24% chose Apple, and we're asking for how many people. We're not asking for percents anymore. We're going to have to do percent of total or percent of number. So your percent was 24%, like we found in the first place. Of means to multiply. Your total was at the top, 175. What did I do wrong though? I can't multiply a percent by a number. I have to change my percent first to a decimal, which means I go over twice, so I have to go over twice here. So I really have to do 0.24 times 175. Alright, y'all pause the video and do it. Alright, you should have got, if you multiplied it all out, I'm not going to multiply it all out because I already did it, but 175 times 0.24 really equals 42. So is that answer reasonable, that 42 people of 175 chose apple pie? Yes. 42 people chose apple pie. Now it says how many people chose cherry. Well, cherry says it's 20%. Remember what we do? We have a percent, we have a total, so we should do percent of total or percent of number. Your percent is 20%, but first you have to change it to a decimal. So we have 0.2 times, what was our total? Good, 175. Okay, again, pause it and y'all work it out. Alright, if you worked it out correctly, you should have worked it all out and you should have got 35 people chose cherry. Now, is that reasonable that 42 chose apple and 35 chose cherry? Yes, because 42, apple has a bigger chunk out of the pie than cherry does. So it completely makes sense. Alright, y'all, I believe that is it. It's a long video, so thanks for hanging in there with me. Hope y'all have a great rest of your day. Bye. Oh my gosh, Aaliyah, that was so